This is lesson 6.5 about solving radical equations. In this first lesson, we're going to learn how to solve radical equations, and we'll also learn how to solve rational exponent equations. This first example is an example of a radical equation because it has a radical in it. And to solve it, we will first have to isolate the radical. So we're going to start by subtracting 3 on each side, and that isolates our radical. Then to eliminate the radical, we'll square both sides because the inverse to a square root is a square. And that gets rid of the radical. Then we have 2x minus 3 equals 25. And now it's a linear equation. We just add 3 on each side and divide by 2 on each side. Once we have a solution, then we have to check it. To check it, you're going to plug the answer for x back into the equation and see if the left side of the equation equals the right side of the equation. When you do this, you can only work on one side of the equation. So I'm going to only do math on the left side and see if the left side equals 8. So 2 times 14 is 28. 28 minus 3 is 25. Square root of 25 is 5. And 3 plus 5 equals 8. So that checks out. So 14 is a solution. Our next example here is a rational exponent equation. So again, we're going to try to isolate the rational exponent part of the equation, which is this. So first thing we'll do is divide by 3. So we have x plus 1 to the 2/3 power equals 4. Then to get rid of the 2/3 power, we raise it to the reciprocal power. So the reciprocal to 2/3 is 3/4, which we do on both sides. The 2/3 times the 3/2 is equal to 1, so we have just eliminated the exponent. On the right side here, we have 4 to the 3/2, which is the same thing as the square root of 4 cubed. The square root of 4 is plus or minus 2, and then if we cube that, we get plus or minus 8. So x plus 1 equals plus or minus 8. Subtracting 1 on each side gives us x equals positive 8 minus 1, which is 7, and negative 8 minus 1, which is negative 9. Now we have to check these solutions to see if they actually work in the equation. So if we